In the aftermath of the Second World War, as geopolitical rivalry hardened into sustained confrontation, telecommunications infrastructure ceased to be viewed merely as commercial or administrative utility and was instead redefined as a strategic asset integral to national power, alliance cohesion, intelligence collection, and crisis management. Telephone exchanges, radio relay networks, undersea cables, microwave towers, satellite links, and switching centers became components of a contested architecture through which information flowed, and in a strategic environment defined by nuclear deterrence and rapid escalation, the speed, resilience, and security of that flow acquired military significance. Early Cold War planners recognized that command and control effectiveness depended on uninterrupted communication between political leadership, military headquarters, and forward-deployed forces, transforming civilian telecommunications grids into essential elements of defense planning. Governments therefore invested heavily in hardening trunk lines, constructing redundant routing pathways, burying cables, shielding switching facilities, and integrating military override capabilities into ostensibly civilian networks, embedding strategic function within public infrastructure. This integration blurred traditional boundaries between commercial operators and national security institutions, as state authorities asserted regulatory control over network standards, encryption protocols, and international routing arrangements to ensure reliability during crisis. Intelligence agencies simultaneously identified telecommunications infrastructure as both target and tool, recognizing that signal interception, traffic analysis, and network penetration could yield insight into adversary intent, readiness, and political deliberation. The dual character of telecommunications as protective shield and exploitable vulnerability shaped policy from the outset, as states sought to secure their own networks while exploiting those of rivals, embedding telecommunications competition into broader Cold War intelligence rivalry. International telephone and telegraph agreements became strategic considerations, with routing corridors and relay stations scrutinized for their geopolitical alignment, as control over nodes determined who could monitor or disrupt transnational flows. Microwave relay systems expanded rapidly in the 1950s and 1960s, offering faster transmission but introducing line-of-sight vulnerabilities that could be intercepted or disrupted, prompting intelligence services to map transmission paths meticulously and to develop specialized equipment for passive collection. Undersea cable networks, though less visible, carried substantial volumes of diplomatic, commercial, and military traffic, and their geographic routing became a matter of strategic calculation, with landfall points and repeater stations monitored for both resilience and access. Satellite communications introduced a new dimension, extending reach across oceans and continents, yet also generating concerns over signal security, orbital vulnerability, and the possibility of adversary monitoring, reinforcing that technological innovation expanded rather than eliminated strategic contestation. Governments classified network schematics and capacity data as sensitive information, recognizing that adversaries could use knowledge of choke points, load limits, and switching dependencies to plan disruption. Continuity of government planning integrated telecommunications redundancy into survival strategy, constructing hardened communication bunkers, alternate switching centers, and emergency broadcast systems designed to function under degraded conditions. Telecommunications firms operated within regulatory frameworks that required cooperation with security services, embedding lawful interception mechanisms and priority circuits that could be activated during crisis. This formalization of state oversight underscored the transformation of infrastructure into strategic terrain as cables and towers became extensions of national defense architecture. Intelligence collection from telecommunications traffic grew more sophisticated as agencies developed capabilities to analyze metadata patterns, route mapping, and call volume fluctuations, extracting strategic insight even when content remained encrypted. Traffic analysis allowed observers to detect mobilization, diplomatic surges, or crisis preparation through changes in communication density, demonstrating that infrastructure revealed behavior through its rhythms as much as through its messages. Adversaries pursued countermeasures, including encryption standardization, traffic padding, and routing diversification, creating an iterative cycle in which protection and exploitation advanced simultaneously. Alliance networks required interoperability, leading to shared standards and joint investment in transnational cables and satellite systems, further intertwining telecommunications with geopolitical alignment. Domestic telecommunications expansion was often justified publicly as modernization or economic development, yet internal planning documents frequently acknowledged defense imperatives, particularly in border regions and strategic corridors. By the mid-1960s, telecommunications infrastructure had become inseparable from strategic calculation, as planners understood that deterrence credibility, crisis signaling, and intelligence awareness all depended on networks that were resilient, surveilled, and capable of rapid adaptation. The Cold War thus recast cables, relay stations, and switching systems as strategic assets whose control, protection, and exploitation shaped the balance of power, embedding information flow at the center of geopolitical competition and laying the foundation for increasingly complex interactions between technology, security, and statecraft in the decades that followed. As the 1960s progressed, the strategic importance of telecommunications infrastructure deepened as military doctrine, intelligence practice, and alliance coordination became increasingly dependent on high-capacity, low-latency information exchange, transforming what had once been national utility systems into integrated components of deterrence architecture. Command and control networks required secure and redundant communication paths capable of surviving disruption, prompting governments to invest in hardened microwave corridors, buried coaxial trunk lines, troposcatter links, and protected switching centers designed to sustain connectivity under conventional or nuclear stress. These investments were rarely described publicly in strategic terms. Yet, defense planning documents consistently emphasized that reliable telecommunications were prerequisites for coherent military response and political decision-making. The integration of civilian and military systems became more formalized, with priority routing protocols established to guarantee that defense traffic could preempt commercial use during crisis, embedding national security contingencies within routine network management. International telecommunications agreements also acquired strategic significance, as cable routes, satellite access rights, and relay station placements reflected geopolitical alignments and could either strengthen or complicate alliance cohesion. Intelligence agencies expanded their focus on infrastructure mapping, cataloging the physical layout of foreign networks, identifying choke points, switching hubs, repeater sites, and satellite ground stations whose disruption or interception would yield disproportionate advantage. Interception capabilities matured alongside infrastructure growth, as specialized listening posts targeted microwave spillover, cable landfalls, and satellite downlinks, turning transmission pathways into collection opportunities. Traffic analysis became increasingly systematic, with intelligence services correlating call patterns, routing changes, and transmission surges to political events and military movements, allowing infrastructure behavior itself to function as an indicator of strategic activity. The vulnerability of line-of-sight microwave systems encouraged adversaries to diversify routing and invest in fiber optic precursors and improved shielding. Yet, each protective measure introduced new complexities and costs, reinforcing the ongoing contest between security and accessibility. Satellite communications further expanded reach, enabling near-global connectivity for diplomatic and military channels, but also raising concerns over orbital congestion, signal interception, and ground station security, prompting parallel investments in encryption and signal authentication. Regulatory regimes tightened as governments required telecommunications operators to incorporate lawful intercept capabilities and to coordinate with security agencies on network design, ensuring that strategic oversight accompanied technological expansion. Domestic infrastructure projects in remote or border regions were often justified through economic development narratives while serving dual purposes of surveillance, rapid military coordination, and alliance reinforcement. Redundancy planning intensified, with alternate routing pathways constructed to mitigate the risk of sabotage, natural disaster, or adversary attack, reflecting the understanding that infrastructure fragility could translate directly into strategic vulnerability. Continuity of government strategies incorporated telecommunications, contingencies, establishing emergency broadcast systems, survivable command links, and hardened nodes capable of operating independently if primary networks were degraded. Intelligence services assessed foreign investment and procurement patterns in telecommunications equipment, recognizing that hardware sourcing could create dependency or vulnerability within allied or adversary networks. The strategic asset character of telecommunications thus extended beyond physical cables and towers to encompass standards bodies, equipment manufacturers, and regulatory institutions that shaped how networks functioned and who controlled them. Alliances increasingly synchronized telecommunications policies to ensure interoperability and secure cross-border routing, embedding infrastructure cooperation within broader defense integration. By the late 1960s, telecommunications infrastructure had become a strategic lattice connecting political authority, military readiness, and intelligence awareness, with its control, resilience, and exploitation influencing the credibility of deterrence and the management of crisis. The Cold War had transformed the invisible pathways of communication into tangible instruments of power, where network architecture and routing decisions carried implications equal to more visible deployments of troops or weapon systems, underscoring that in an era defined by rapid escalation and global reach, the ability to transmit and monitor information was itself a determinant of strategic advantage. As the 1970s unfolded, telecommunications infrastructure became even more deeply embedded within strategic competition as global connectivity expanded and the scale of data transmission increased dramatically, compelling governments to treat network architecture not only as a facilitator of communication, but as a determinant of geopolitical leverage. The growth of international direct dialing, high-capacity submarine cables, and expanded satellite constellations multiplied the volume of transnational traffic, making telecommunications both a conduit for diplomacy and a reservoir of intelligence. States invested heavily in modern switching systems capable of handling increased load while simultaneously incorporating security features such as priority circuits, secure trunks, and cryptographic overlays designed to protect sensitive channels. Intelligence agencies intensified their infrastructure analysis, examining how modernization projects altered routing logic, load distribution, and vulnerability profiles, recognizing that subtle design choices could either enhance resilience or create exploitable choke points. Microwave relay chains continued to carry significant domestic and cross-border traffic, and their predictable line-of-sight characteristics enabled both surveillance and targeting strategies, prompting countermeasures that included signal narrowing, route diversification, and underground cabling. Undersea cable expansion remained central to global connectivity, and the selection of landing sites and repeater spacing reflected not only engineering considerations, but strategic calculations regarding surveillance risk and physical security. Satellite communications matured into a primary backbone for diplomatic and military coordination across continents, yet the shared use of commercial satellites introduced complexities regarding encryption standards, access control, and potential monitoring by adversaries. Encryption technology became increasingly integral to telecommunications security, with governments standardizing cryptographic protocols for official traffic, while intelligence agencies simultaneously worked to penetrate or circumvent those protections abroad. Traffic analysis grew more refined as computing power improved, enabling agencies to correlate metadata patterns over extended periods and to detect anomalies indicative of mobilization, negotiation surges, or covert coordination. Telecommunications infrastructure thus functioned as both a defensive shield and an intelligence sensor, revealing strategic posture through its rhythms even when message content remained inaccessible. Regulatory oversight tightened in many states, formalizing requirements for interception capability, emergency access, and collaboration between operators and security services, embedding intelligence considerations into routine network governance. Alliances coordinated telecommunications standards to ensure interoperability of secure channels and redundancy in cross-border routing, making infrastructure cooperation a component of collective defense. Economic policy intersected with strategic planning, as states evaluated the risks of relying on foreign-manufactured switching equipment or satellite components, recognizing that supply chain dependency could introduce vulnerabilities. Sabotage and disruption planning were also considered, as military doctrines acknowledged that telecommunications nodes constituted high-value targets whose impairment could degrade command coherence and public morale. Consequently, physical protection measures were expanded, including hardened facilities, access controls, and distributed switching architectures designed to prevent single-point failure. Continuity planning incorporated telecommunications recovery protocols, ensuring that emergency broadcast capabilities and alternate routing pathways could sustain governance in the event of severe disruption. The strategic valuation of infrastructure extended to research and development investment, as governments supported innovation in digital switching, fiber optic experimentation, and advanced signal processing to maintain both capacity and security advantage. By the mid-1970s, telecommunications networks had become indispensable strategic assets whose control influenced diplomatic flexibility, military responsiveness, and intelligence reach. The Cold War environment ensured that expansion of connectivity was never purely commercial, as each technological advance was assessed for its implications on surveillance potential, vulnerability exposure, and alliance integration. Infrastructure planning documents increasingly reflected a dual-use philosophy in which modernization objectives were aligned with resilience and intelligence access, reinforcing the idea that communications architecture itself was a form of strategic capital. As global information flows accelerated, the competition to secure, monitor, and shape those flows intensified. Correspondingly, embedding telecommunications infrastructure firmly within the broader matrix of Cold War power politics. As the late 1970s transitioned into the early 1980s, telecommunications infrastructure assumed an even more explicit strategic identity, as digital switching, early fiber optic experimentation, and expanded satellite coverage transformed the scale and speed of global information exchange, prompting governments to reassess both vulnerability and advantage within increasingly interconnected systems. Digitalization improved capacity and routing efficiency, yet it also introduced software-dependent control points whose compromise could affect wide segments of national networks, reinforcing the need for cybersecurity measures. Even before the term was widely institutionalized, intelligence agencies monitored modernization programs abroad to determine how digital integration altered signal patterns, encryption practices, and routing logic, recognizing that changes in architecture could either conceal or expose strategic communication flows. Fiber optic trials promised greater bandwidth and resistance to electromagnetic interference, but their physical deployment created new critical nodes, amplification sites, junction boxes, landing stations, whose protection and monitoring became matters of defense planning. Satellite systems expanded in both commercial and governmental use, and the proliferation of Earth stations increased potential interception vectors, while simultaneously complicating surveillance due to signal multiplexing and encryption layering. Regulatory frameworks adapted to these developments by mandating stronger cryptographic standards for official channels and expanding lawful intercept. Requirements within domestic systems, embedding intelligence oversight more deeply into telecommunications governance. Alliances intensified coordination over secure communication standards, ensuring compatibility of encryption equipment and redundancy across transnational links, thereby strengthening collective resilience against disruption. Intelligence collection strategies evolved in response to increased digital traffic, incorporating advanced signal processing and traffic modeling to extract strategic insight from metadata, even when content remained inaccessible. Infrastructure mapping became more detailed, with agencies cataloging not only physical assets, but logical routing schemas, software dependencies, and network management hierarchies that determined how traffic was prioritized and redirected during crisis. Contingency planning assumed that adversaries might target telecommunications hubs in conjunction with military operations, prompting investment in hardened switching, centers, distributed architectures, and mobile communication platforms capable of rapid deployment. Economic competition intersected with strategic planning as states evaluated telecommunications, technology exports, and procurement contracts through a security lens, assessing whether foreign-supplied equipment could introduce latent vulnerabilities or backdoor access. Emergency broadcast systems and national alert frameworks were modernized to ensure rapid dissemination of government directives, reflecting recognition that information control during crisis was as critical as force deployment. Intelligence agencies studied foreign telecommunications expansion in developing regions, understanding that control over infrastructure construction, satellite leasing, and switching technology could shape geopolitical alignment and influence local policy. Infrastructure thus became a means of projecting power indirectly as investment and technical assistance created long-term dependencies within global communication networks. The strategic value of telecommunications extended to financial systems, air traffic coordination, and energy grid management, all of which depended on reliable connectivity and therefore fell within the scope of security planning. Encryption debates intensified as governments balanced the desire for commercial competitiveness with the need to preserve lawful interception capabilities, illustrating the tension between economic openness and intelligence access. By the early 1980s, telecommunications infrastructure was recognized across defense and intelligence communities as a strategic domain whose resilience, interoperability, and surveillance potential influenced deterrent stability as directly as traditional military assets. The Cold War had transformed cables, satellites, switches, and relay towers into instruments of statecraft, where design decisions carried geopolitical weight and where control over information pathways could amplify or constrain national power. This period demonstrated that telecommunications were no longer passive conduits, but active strategic assets embedded within command systems, intelligence architectures, and alliance frameworks, shaping the conduct of competition in an era increasingly defined by speed, connectivity, and technological interdependence. As the early to mid-1980s progressed, telecommunications infrastructure became inseparable from strategic command systems, economic stability, and alliance integration, reinforcing its status as a central asset in Cold War power projection and risk management. Digital switching centers increasingly served as nerve hubs for both civilian and defense communication, and their survivability under crisis conditions became a matter of formal contingency planning, prompting investment in distributed architectures designed to prevent catastrophic failure from single-point disruption. The growing interdependence between telecommunications and financial networks elevated the stakes of infrastructure resilience, as policymakers recognized that economic paralysis could carry strategic consequences comparable to military degradation. Intelligence agencies expanded surveillance methodologies to account for packetized data, multiplex channels, and encrypted signaling layers, refining traffic analysis techniques capable of detecting mobilization patterns, diplomatic surges, or command coordination, even when direct content access was unavailable. Satellite ground stations multiplied, and with them the complexity of monitoring and protecting uplink and downlink paths, as signal spillover, encryption protocols, and frequency management became arenas of both technical and strategic competition. Governments evaluated the geopolitical implications of telecommunications export policy, aware that supplying switching equipment, satellites, or cable-laying expertise could extend influence while also embedding technical standards aligned with national security interests. Alliance frameworks incorporated telecommunications redundancy into defense planning, ensuring that cross-border fiber corridors, microwave chains, and satellite links could sustain command cohesion under degraded conditions. Regulatory authorities required network operators to maintain emergency access provisions, prioritize defense traffic, and coordinate closely with security agencies, formalizing the integration of strategic oversight into daily network operation. Intelligence communities monitored foreign procurement of digital systems and encryption devices, assessing whether modernization efforts abroad enhanced resilience or created exploitable vulnerabilities. Telecommunications infrastructure also became a target of contingency planning for disruption operations, as military doctrines acknowledged that disabling communication hubs could impair adversary coordination without direct confrontation. Protective measures expanded accordingly, including physical hardening of facilities, guarded access to cable landings, and distributed control centers designed to assume operations if primary sites were compromised. Encryption technology matured significantly during this period, leading to debates within governments about balancing commercial adoption of strong cryptography against intelligence access requirements, reflecting the persistent tension between economic modernization and surveillance capability. Traffic modeling grew more sophisticated, allowing analysts to detect anomalies within vast data flows and to correlate infrastructure behavior with geopolitical developments, reinforcing the insight that networks revealed intent through structural patterns. Global connectivity increased dramatically, and telecommunications corporations became transnational actors whose infrastructure decisions carried strategic consequences, prompting closer collaboration between corporate leadership and national security institutions. continuity of government frameworks incorporated advanced telecommunications contingencies, including mobile command posts and hardened relay systems capable of functioning independently from commercial grids. The cumulative effect of these developments was the recognition that telecommunications infrastructure constituted a strategic ecosystem rather than isolated assets, where cables, satellites, switches, and regulatory frameworks interacted to shape national power. By the mid-1980s, the Cold War had transformed telecommunications from supporting utility into central instrument of statecraft, influencing deterrence credibility, intelligence reach, alliance cohesion, and economic resilience. Infrastructure planning was inseparable from security planning, and the architecture of connectivity itself became a reflection of geopolitical alignment. The strategic competition over telecommunications was therefore not confined to interception or disruption alone, but extended to standards, setting, technology diffusion, and control over information corridors that defined the tempo of global interaction. This era underscored that the Cold War contest increasingly unfolded across networks rather than battlefields, and that mastery of telecommunications infrastructure offered leverage as consequential as traditional military deployment in shaping the balance of power. As the late 1980s approached, telecommunications infrastructure operated within a strategic landscape marked by accelerating globalization and political transformation. Yet its status as a core asset of national security remained firmly intact, shaped by decades of integration into command systems, intelligence operations, and alliance coordination. Digital networks expanded in capacity and complexity, incorporating early fiber optic backbones and advanced switching software that enhanced efficiency while introducing new forms of dependency on centralized control logic, reinforcing the necessity of redundancy and oversight. Intelligence agencies adapted collection strategies to evolving architectures, focusing on metadata correlation, routing analysis, and anomaly detection across increasingly layered communication channels. Acknowledging that infrastructure behavior itself continued to provide strategic insight even as encryption standards strengthened. Satellite communications diversified into mixed commercial government constellations, prompting revised security protocols to protect sensitive traffic amid shared platforms. Regulatory institutions balanced liberalization trends with enduring security mandates, ensuring that modernization did not erode lawful interception capabilities or crisis prioritization mechanisms embedded within network governance. Alliance telecommunications planning emphasized interoperability of secure systems and resilience against disruption, preserving collective defense coherence despite broader geopolitical recalibration. Economic policy and national security remained intertwined as states assessed foreign investment in domestic telecommunications sectors, wary that ownership or equipment sourcing could translate into leverage over strategic nodes. Continuity of government planning evolved to reflect new technological realities, integrating mobile and distributed communication systems capable of sustaining leadership coordination under degraded conditions. Infrastructure mapping remained a continuous intelligence function, cataloging fiber routes, switching hierarchies, satellite ground stations, and cross-border corridors to anticipate both vulnerability and opportunity. Telecommunications companies increasingly operated as global actors, yet their infrastructure decisions were scrutinized through a strategic lens, recognizing that connectivity pathways influence diplomatic and economic alignment. Encryption debates intensified as digital commerce expanded, but security services retained priority access mechanisms within national frameworks, preserving intelligence reach within evolving technical standards. By the close of the Cold War, telecommunications infrastructure had become a fully institutionalized strategic domain, embedded within military doctrine, intelligence architecture, economic planning, and alliance governance. Its transformation from civilian utility to central asset reflected recognition that control over information flow shaped not only battlefield coordination, but diplomatic leverage and economic resilience. The cumulative experience demonstrated that telecommunications were instruments of power whose design, routing, and regulation carried geopolitical consequence equal to more visible deployments of force. As political confrontation moderated, the infrastructure built under decades of rivalry remained in place, a testament to how deeply connectivity had been woven into strategic calculation. The Cold War had permanently altered the perception of telecommunications, establishing that in an era defined by speed, interdependence, and surveillance, networks themselves constituted terrain, and mastery of that terrain was essential to maintaining national influence and stability. In the final assessment of how the Cold War turned telecommunications infrastructure into strategic assets, the historical record reveals a transformation driven not by technological curiosity alone, but by the structural demands of deterrence, intelligence competition, alliance integration, and crisis management. What began as national utility systems for commercial and administrative exchange evolved into layered strategic architectures embedded within military command networks, intelligence collection frameworks, regulatory regimes, and geopolitical planning. Cables, microwave relays, satellite links, switching centers, and fiber corridors became nodes of power whose resilience determined the continuity of governance and whose vulnerabilities invited surveillance or disruption. Governments institutionalized priority routing, lawful interception, encryption standards, and redundancy planning, ensuring that telecommunications operated as extensions of national defense rather than neutral conduits. Intelligence agencies mapped infrastructure domestically and abroad, exploiting transmission pathways for traffic analysis, metadata modeling, and signal interception while simultaneously protecting their own networks through hardening, diversification, and cryptographic reinforcement. Alliances coordinated telecommunications standards and cross-border redundancy, embedding connectivity within collective security architecture, and recognizing that interoperability of secure communication was as critical as force deployment. Economic modernization intersected with strategic calculation as procurement decisions, export controls, and technology diffusion shaped geopolitical alignment and influence. Regulatory oversight ensured that commercial expansion did not dilute security prerogatives, preserving access and crisis control within increasingly complex digital systems. By the end of the Cold War, telecommunications infrastructure had become a strategic ecosystem in which physical hardware, software logic, governance mechanisms, and intelligence capabilities interacted continuously. Its battlefield character was defined less by overt sabotage than by the persistent contest over control, surveillance, resilience, and influence within global information corridors. The Cold War permanently altered the strategic valuation of connectivity, demonstrating that power in the modern era depended not only on weapons and territory, but on mastery of the networks that carried commands, negotiations, and economic exchange. The infrastructure constructed and fortified during decades of rivalry remained as enduring evidence that telecommunications were no longer ancillary utilities, but central instruments of statecraft, shaping deterrence credibility, intelligence, reach, alliance cohesion, and national stability across the global strategic landscape.